A quick presentation on building data pipelines, so data engineering pipelines, to run in Trino, open source Trino, the query engine with SQL and or Python. Hey, by the way, I'm Lester Martin. I am a developer advocate at Starburst, so Starburst, Trino, and all kinds of other good stuff, and been around for a little while, including time with Trino and lots of other quote-unquote big data kinds of technologies. So why don't we jump on in, and like anything, we always have to have our history lesson. So the high-level history lesson in that big data space or data lake analytics was way back around the early 2000s. In fact, it happened at Yahoo as much as anywhere else. It used to really be a big issue at those times. And we were trying to do metrics, and we were trying to do analytics, and try to look at web trends and all kinds of stuff by the fact that everyone was on the World Wide Web. Now, that might have been before your time, but pretty seems ubiquitous today, but it was a big deal back then. And the data systems that were around just couldn't scale up, or maybe you just couldn't afford to scale it. Maybe there was a solution, but it was so pricey, it just outweighed all the benefits. So Apache Hadoop was created, came out of the couple Google papers around a file system and around a MapReduce engine concept, and we actually were starting to be able to do analytics on those large scale data sets. Shortly thereafter, good folks at a lot of places said that's neat that we can do that, but I have to do that way back then in this thing called Java MapReduce. As a Java programmer myself who did get to write some Java MapReduce, it was interesting and fun, lots of good science fair experiments, but the reality, most people know SQL. So, folks at Facebook created a thing called Apache Hive, and you've probably heard of that one, Hive, and Hadoop, of course. And now we are able to write SQL statements that got torn down behind the scenes into something Hadoop itself could understand. And it was built for just like all of Hadoop, since these were big jobs, it took a while to run. They were built with a lot of resiliency and restarting and those kinds of things. And in fact, these data sets could be so big, the questions could be so big that maybe in the earliest of days, just a handful of queries might be run. Just as likely as they scaled up, it took a while for these queries to run. Go get a coffee, go get lunch, or hey, let's call it a day and come back tomorrow. So also, shortly around that time, maybe a little bit later, there at Facebook, a project got created called Presto. Presto, ergo Trino today. There's two lines of Presto. There's a thing called PrestoDB today, and there's a thing called Trino. Going to stay out of the history on that much just to keep us moving forward. But the four folks that created that, three of them came to my company, Starburst, and created it kind of as a support company around Presto. And then Eric up there came a little later as a distinguished principal engineer, real brilliant fella as well. And this open source engine is really about, like all these, use distributed computing, large sets of computers all over the place. It was a true break compute from storage, which was kind of funny in that time era because that's really what, Hadoop in many ways was doing. It was saying, hey, I got the cluster and the data spread all over the place. Why don't I push the compute to the storage? A really good idea, has lots of good values, but in this world we can scale up and scale fast, not being coupled to that. Super fast, super performant, a lot of plugins that we'll talk about briefly here, and of course it's based on classic ANSI SQL, so we can run SQL on anything. In fact, those data sources I'm going to mention, we can run SQL on them, even if they don't support SQL. And this engine called Trino that I care a lot about, its little logo and mascot on the left corner is a fellow named Commander Bun Bun. We talked about most of the topics over there. That fourth checkbox is worth mentioning that over there when Iceberg was getting created over at Netflix, the engine that was being used was Trino. So we like to think of Iceberg was designed for Trino. Iceberg was designed for lots of compute engines. It was just the primary original compute engine as it was being created. And you see a number of logos that you would easily recognize, and some of the scale of data sets that are being processed on Trino on that middle bar. A lot of folks participating, a lot of contributors, a lot of stars, all that kind of good stuff. And then probably maybe one of the last times I plugged my company today, or maybe it was the last one, is that Starburst. We like to think of ourselves as the Trino company. As I mentioned, the folks that created it came over here. We have the most committers, best experience, all that kind of good stuff. But in fairness, Trino is used lots of places as an open source solution without any runtime, without any support from any company. And there are other companies that sell Trino under a different name, under the covers, it being Trino. If you keep looking a little deeper and talk about Trino, it's going to look in some ways like a lot of distributed computing technologies that either have a brain and workers kind of architecture, or some of them, like Kafka example, has just a peer-based solution, no master. They're all kind of taking the responsibility, but we take the original one. I think that most people, many services do well. A brain, the coordinator, and then the scale out. So the brain's going to figure out what to do and then assign all the work. Imagine that to the workers. And we're showing that's where we'll scale up and scale down. Now, if we had a longer time, I'd love to just kind of walk you through all these steps, but I'll just make a few points. If you look in the very center, you see what we just said. Coordinator, sending data, sending his responsibilities and getting data back from those workers. And then on the far right, you see a person or a process or whatever, asking SQL, getting results. That's kind of the overarching black box in out. You see lots of other things for authentication and authorization on the top. But really what I want to point out is that coordinator needs metadata. Metadata is going to exist. Many of the data sources have their own metadata. We can also have a metadata, or nowadays we like to use the term catalogs that have usually for data lakes. In our case, we can actually enhance metadata from systems like Oracle and Teradata if we choose to do that, if you choose to employ it that way. But we get that metadata, the characteristics of data, the size and scale of data, and then from that we can map out work. So the coordinator is not really lifting real data, it's assigning the work to do all that down into those workers. That's why you see on the low left, the data is coming in there. Last thing while I'm here, on the far left, kind of clumped them up in a handful of categories here, but we're really trying to say that we got about 50 connectors, 50 plus connectors, I guess, at this point, that can pull data from a lot of different places. And that's pretty darn awesome. Let's see that as we get a little further. Oh yeah, there we go. Next slide up. Rich ecosystem. This is not the logo list of everything that we can talk to from Trino, or even Starburst does some proprietary connectors as well. But this gives you an idea of what we're talking about. Data lakes, normal databases, NoSQL databases, all kinds of weird stuff on the left. And even applications. We can connect to and see applications as data. We can run queries against them. And what's really cool about this is we can write federated queries. We can run queries against all these data sets joined together in one SQL statement. Pretty powerful in my book. Now, the talk today was about using Trino for ETL workloads, data pipelines, ELT, whatever you like to call that. Transformational processing, that's what I like to call it. And the reality is pretty much as soon as we got out the door, so got created in 2012, used in a number of places, but formally productionized there at Facebook around 2013, I guess you could say. And then before you know it, people realized, hey, they were taking the approach of use high for those big hard questions that could take forever, or use into our batch cycles. But they started realizing, what if I ran some batch in Trino? Would that be good? So we started seeing activity there. And that might mean they separated clusters, so they're not trying to overwhelm the interactive queries, all kinds of choices. But people started using Trino in a batch situation right out of the gate. In fact, you can see right there of workloads, what were happening there. 50% of the ETL workloads, this is at Facebook, by 2018 were landing in 50% of the batch workloads, the transformation processing workloads were landing in Trino, and then overarchingly, the vast majority of new interactive querying and data application, so on and so forth, were leveraging Trino. And again, why? Kind of said it already. Massively parallel processing engine that's fast, cheap, ANSI SQL based, and it can virtualize and federate a variety of data sources, not just the data lake. And then, right, like it says at the bottom, soon after Facebook started doing this, other big players started realizing, hey, I can use Trino instead of something like Hive for my batch ETL jobs. Now, the problem really with using Trino instead of something like a Hive for your batch concerns is the fact that part of the architectural design in Trino, in many ways, it's not a lot different than Spark. In many ways, it's not a lot different than Hive. These systems, and if you're not familiar with this overarching kind of how do you take work and parallelize it, but then not get too far, and then do another, and this is called stage-based processing, or these query plans, or these directed acyclic graphs, then bear with me. But if you are familiar with what I'm talking about, what Trino really said is that let's not do anything that requires, or try not to do anything that requires a disk. Let's read data from where it is, and let's use it, work on it, process it, stream it to the next step, and go as fast as we can. But ultimately, if something goes wrong along that journey, the user gets an append. Hey, your query blew up. And in the classic kind of a Trino world, that means, try it again. A human's over there, or an application that has some kind of real-time component. Even if it's an automated application, it may try again, and those things. That's no good for when a query is running for half an hour, then 90 minutes, and maybe it's a 2.5 hour job. That's just what it takes. And it's 2 hours and 12 minutes into it, and something goes wrong, it blows up, and we have no replay. Everything has to start back from the beginning again, because we don't keep a lot of that intermediary data. So they call it spooled data, stage-based data, lots of cool terms for that. And it also really started to, it does put a little bit of a rub in some of the more interesting techniques out there. I'll just mention something like adaptive query execution. Trino says, I figured out the entire query plan. I know what I'm going to do. I'm going to run it to ground. And the reality is that's not always enough information to make the perfect solution. Probably be a pretty good one. But if you could stop at every stage and say, okay, now that I did that, replan, rethink, and the original architecture isn't built around that kind of concept. So what do the good folks that write Trino do? Well, like you do anything else, you say, let's solve a problem. Let's solve a problem. And the problem they solved is, how can we handle not just those big stages that I talked about, but tasks within those stages as well. And what about, hey, it's a little bit later, we're 30 minutes into this job, the cluster looks different, there's more resources over here versus there. How can we try to make this be more fault tolerant? Well, they implemented a thing called fault-tolerant execution mode. That mode today is a cluster level setting. There's some work that's happening at Starburst that would say eventually we want to make it job load oriented, but you can do that with a gateway in front of it based on resource groups, and send your batch. You can go to one place, but if you tell me who you are or something that helps in that window, I can send you to a particular one. But it's a different cluster execution mode, and it does in many ways what Spark does, what Hive does itself. So it stores information coming off of each stage into some intermediary location. In fact, we tried to do it a lot more non-machine specific. We said, hey, even that's compute and storage separated, so we even had more durability should something go wrong. We don't even lose the data that may be on a machine that may have failed or something like that. So we get that stage by stage execution. So, and that's good. We want that to occur as fast as we can. So we talked about the initial start of this was let's build some ETL or transformation processings with Trino using Python or SQL. So it doesn't hurt to talk about, and I used the word medallion architecture. Maybe I didn't. Maybe I did or didn't. Medallion architecture. I like the phrases instead of silver, bronze, silver, gold. I like the phrases land, structure, consume. Now, if anyone tells you the medallion architecture is the perfect fit for everything, it's not, but it is a perfect start to say likely everything has at least these kinds of layers. You might have more. Probably don't have less. But I use words, again, that mean something to me. Data that survive, that shows up. So we're ingesting data from upstream applications. We're landing that raw data. We're keeping it forever, or as long as we can afford to keep it. Why? Because whatever we start to do with it, we might have done it wrong, or the laws may change, or we may merge with another company, or a new question comes out and it was data that we left on the shop floor that we didn't bring into that silver structured layer. So think of that. Silver layer is it's normalized, it's valid, it's correct. We could run our business off of it, but it may or may not be the fastest thing in the world. So absolutely, we're going to do some other things. We're going to it could be views, it could be aggregated data that we rolled up, it could be materialized views of data from lots of places, just to make the question and build, I guess, query-focused data sets. We think about that gold layer. And then people or processes that I mentioned earlier can come and ask all kinds of good questions, likely from that consume layer, but from anywhere, technically from anywhere, from structure, even way out in the raw. So that's what we're trying to do. That's a high level. Almost all of us are doing something like that. Almost all of us are using layers, something like that. And if we want to overlay terms like data pipelines, in that everything I just described is a data pipeline. Or you might argue that the smaller pieces in that are the pipelines. That's debatable. I'm going to let you find that out. Logically, it's one long data pipeline, and it's very likely that ingestion kind of stuff I said is, for a lot of folks, we're going to use the ELT kind of pattern. So that's our extracting data from somewhere and loading it. That could be batch, that could be streaming, that could be mainly those two, I guess you could say, is we're going to get stuff. And then, of course, we're going to transform it along the way. Likely we'll just transform the raw once. Could be more, but likely once. And then in that structure tier, we may transform that many times to make better and faster and more business-friendly, consumer-friendly kind of data sets that are easy to write queries on, that run really, really fast. But, if it made sense to you, could offer that structure layer up to your business folks as well. So ELT and T and T and T and T. And these could be forked off, not just once you get that data, especially to the structure layer, you might do a whole bunch of transforms to different consumed data sets. Or consumed data sets may be built with other ones. That's not all, that's pretty normal stuff. So that's the place that I'm talking about in my deal here. I'm saying, hey, you can build those with SQL or Python. And I think a lot of people know that already. Plenty of people are building, Spark SQL or just Spark jobs that, the data showed up, maybe they say will or won't do front-end querying, but that transformation jobs, those kinds of activities, I'm just going to write that today with something like Spark and get the benefits that we talked about, parallelization, all that kind of good stuff. You could write that in SQL, even back in Hive. You can do it Trino, you can do it any SQL engine. And if you did Spark SQL, in fact, that's what you're writing. You're writing SQL wrapped with a little bit of Java call, a little bit of a Python or Scala or Java calls wrapped around it. But you have choices there, and it will be just fine at all. So what's some of the goods and the bads about using SQL? Well, everyone knows what it means usually, and it's often pretty succinct. It doesn't have all this wrapper stuff around it. It just says, get this, get that, from here, from there, put it together. But the cons could be what you see there, right? Maybe not the most unit tested in the world, not always the funnest thing to debug. And as it says, no real-time debugging is fair enough. You're just going to let it run to ground, and then go see what happened and everything. Keeping track of SQL, most shops don't really bring that stuff under version control and that kind of stuff. And even when they do, it's not always the easiest. You can just move a subquery or pull it out of a subquery and make it a common table expression at the top. And your diff says, wow, you did something dramatic. Maybe that's all you did. It was really something simple, but it looks so intense from your difference output. And then, of course, I think all of us at some point in our career, or if you haven't, you're going to one day, you're going to walk in and get asked to take a look at this query that is going to be nothing like what you see on screen there. It's going to go on for screen after screen after screen, and you're just going to go, wow, this is I'm glad I started the day off with a cup of coffee. So it definitely could get much more complicated as the complexity goes. We usually build this all together in one SQL. We don't think about building little temp sets and all that kind of stuff, or at least logical things. So what's the alternative, of course? Using Python. When we say Python, we're probably talking about the de facto approach for that here is probably using Spark. So things like PySpark, and that's the example code if you look close in there. And what's reusable, what's good about it? Well, it's software. It's software, and you have all those abilities that you have in the software development life cycles and tools, continuous building and testing and putting things through rigor around deployment, not just deployment, but merging code requests via PRs and all this kind of good stuff. And of course, you can throw in things that something like Python has. Lots of libraries that maybe aren't so available right out of the gate in something like SQL too easily. Probably the biggest con is, it doesn't say it there, but the biggest con I would say is if you're not a programmer, you're probably going to go, But even if you are a programmer at times, it's fair to say doing data frames with Python can feel a little verbose you're like, man, sometimes the query is quicker, shorter than the code. The more complicated it gets, I think it's kind of to flip the direction, or at least you can break it into pieces. So again, it gets compartmentalized, or separation of concerns, and feels a little bit better. There's other cons, like there's always 2 or 3 ways to do everything in data frame APIs, but that's okay. So data frame APIs are what we're talking about. And those data frame APIs, we'll talk about the engines themselves, but very likely, especially if they run into a SQL engine like Trino, the query that gets built from that verbose API ends up building some really nasty looking queries. On the right, it shows looks like 141 line query, and arguably it's trying to tell you, hey, this is the same thing as on the left over there, based on how it was assembled in the code itself, in the data frame API. Take this, join it with that, do something, filter it out, change the names of the columns, etc. Then join it with another data set, and it can feel like a lot, but it's easy to document. We're working on it step by step, but it's very easy to debug. But it looks scary, so you think, oh no, Lester, you told me, isn't it terrible to take a gigantic query? No, I said it's terrible to try to figure out what's going on in a gigantic query. The good news is these engines, just like I wrote the cumin query, and the data frame engine created a query to run at the end of the day, when the engine takes all that, a good powerful engine like Trino, and using its cost-based optimizer can work through that code and ultimately say, I see what to do. In this case, 1, 2, 3, 4, 5, looks like a 6-stage job. Those big green boxes are stages. And those of us that kind of can read this quickly kind of realize, there's a big join in the middle, at least of 3 things, maybe even a join in the lower left to make the 4th join, and then maybe some aggregation, filtering, that kind of stuff. What am I trying to say? I'm going to go backwards. You write as clean as you can, data frame. You write it in the data frame API. It builds some pretty interesting query, but we're going to let the cost-based optimizer, the engine itself, sort that out, break it apart, and say, I can run that. I can run that efficiently, and that's a good thing. So when we talk about Trino, we're not talking about running PySpark. PySpark runs in a Spark cluster. Pretty cool stuff. I'm not denying that. But if you want to run that workload, you already have a Trino cluster. You wanted to write in Python, not SQL. The good news is you got a couple options. It kind of depends on a few things. I'll tell you what these are, and then I'll give you some little what might make more sense for you depending on your situation. There's a thing called Starburst. I'll show you that in just a second. And then there's this other project called IBIS. So what's Starburst all about? Well, it's about making sure, it's about an API that strives to look as close as possible, code method by method, argument, all that good stuff, as you might have written your PySpark code. But the real difference is, just like PySpark and all these functional languages are lazy executed. That means until you hit some function that says do some input output, bring me the results, persist the results, something like that, share the results. They don't actually do anything yet. They just start building up all these instructions, like a long instruction block of things to do. PySpark itself Once it gets all of that and gets to say, it says to go for it, it sends information off to its own cluster and tells it how to do work its own way. So it doesn't distribute. If you wrote it in SQL, it breaks the SQL down and turns it into an underlying API called the RDD, if anyone's familiar with that. But what Starburst does is the same thing when you said something like you see in the top, show me on the screen what's happening. It's going to take all that data flow definition you just created and ultimately turn that into SQL that the engine now can say, cool, I got this very verbose looking SQL, but I trust you, and I'm thankful you trusted me to sort this out and run some efficient query, and then ultimately hand the results back. And handing them back could be a show, which just put it on the screen, or it could have been persist this the disk or write it to this table, those kinds of things, and you still get a result like, hey, I'm done, something like that. So the heavy lifting is done in Trino. We're taking Python, breaking it down to SQL. It still follows that same lazy execution model that PySpark and all and functional languages themselves are all about. And as I said earlier, it strives very hard to run to look like PySpark. Meaning what? If you already have some code using PySpark, should you be able to bring that and change a few lines at the beginning how a session starts and then say, hey, I'll run it? You should. I'm not going to say it always works perfectly, but we've had customers that have taken that information, taken that approach, and been able to get off of a Spark infrastructure, maybe even a Databricks infrastructure. The bad news, you're going to see in my pro and con in a minute, is that isn't part of open source Trino. It's pretty darn close. And arguably maybe someone in the, I'm going to leave it at that. It's not open source Trino. It is part of Starburst code, Starburst Galaxy, Starburst Enterprise. The second big alternative here, again, you can always write it straight in PySpark. If that's what you want to do, you just need a different infrastructure. It won't be running it in Trino. But IBIS is, as it says up here at top, it's a common data frame library out there. And it lets you write Python. And depending on when you write the same code, but you say, hey, run this on Trino, run this on Snowflake, run it on PySpark of all things as well. So this is, if you think of Trino bringing optionality to a SQL engine that says I can talk to all kinds of data sources, etc., then IBIS is in many ways kind of that same optionality for Python data frame code that says, hey, at runtime, you tell me where you want to do it. You talk in a common language, and I will I'll make sure I have a plugin that works with that other engine, and I'll kick it off and monitor it and let you know how it went. And that's pretty powerful stuff. And it has a pretty big list of things. I'm sure at this point the list is a little, it's probably a little bit bigger. Probably not too much bigger. I think there's less than 20 of those things out there. But absolutely, Trino would be one of those options. And if you look at the code itself, I would call them similar APIs. Starburst, as I mentioned, is much closer to PySpark itself. And IBIS is still pretty darn close. There are multiple data frame APIs in existence in the world. Ones that aren't distributed, ones that are local, all kinds of stuff. But they all follow the same general principles. They have the same general functions, especially with structured data that you see here on screen. So you can definitely take a look at this or sync up later and take it line by line. I wasn't going to just break each one down, but I wanted to show you that for the most part, they're very similar. But if you were taking your PySpark code, you're going to have to adjust it as you go along to tackle and adjust with what you see there. But nothing into the world there. And just like I said, an engine like Trino that took a query from a human and took a query generated by a data frame API framework that could send it to a SQL engine like Trino. The reality is, this is a perfect example. These are going to have similar results. That same API on both ones, going through different pieces of code and send to different places. Ultimately, what do they end up doing? They end up sending queries to Starburst and Starburst to Trino, excuse me. And what's going to happen is Trino, the query plan engine, the cost-based optimizer, is going to figure it out. And while I've seen some slight differences here and there, it's fair to say they are similar results. I think actually Starburst and Trino does seem to do slightly better on a few things, but again, haven't done enough exhaustive compare and contrast and even chase it down. But I've seen a few times where things were a little bit more optimized than that, but very quality stuff that you see in IBIS. So in your data pipelines, again, this is if you chose, well, I guess this is a statement that says absolutely Trino is a safe, comfortable place to run your data pipelines. And it could be for a variety of reasons. Usually one of the first ones is you're comfortable running your data pipeline code with SQL. Usually wrap it with some kind of orchestration, scheduling kind of solution. I'll just say something DBT, SQL Mesh, others, or just some simple, straightforward orchestrator, Airflow and others, and to coordinate all those steps. So if you're comfortable with that, absolutely, you can do that stuff here as well as any other engine, especially with fault-tolerant mode, to get you that guaranteed, hey, I'm going to run that job to ground despite problems they may surface. And maybe not the reason you initially come to Trino, but if you are deciding, hey, I'm Trino, and I've done some work in SQL, or I just don't want to do SQL, I really want to do it in Python, you've got you some options there as well. And my recommendations, well, if you're doing SQL, you do SQL. There's no recommendation there. But the data frame API recommendation really kind of boils down to, what are you using? And if you are using Starburst, while you could use IBIS and it wouldn't be a bad solution, I would push you down the Starburst path, mainly because of those two reasons I said along the way. Heuristically, it seems to me that you're more likely going to get some better results from Trino than IBIS. But I'm not talking about totally wrong by any stretch. I mean, nuanced changes, because at heart, they should be generating something pretty darn close. The same kind of SQL, and Trino is really receiving a SQL statement. So I think the generalization that IBIS has to do might be a little bit of the cause of that. And then, of course, the good news is you can optimize each one of those plugins to get you there. But that's where my assessment is today. And of course, if you're already familiar with PySpark, because you've been doing that, easy breezy. If you want to import from PySpark, easy breezy. Or if you want to give yourself some optionality later to port from Starburst back to PySpark, again, makes the code a lot easier when you just have to change some initial lines about how you create this kind of session and get started, and the rest of the code's the same. But absolutely, if you're running your own solution or just have some other vendors hosted or just managed software for Trino, then I would look to IBIS, mainly because it's your biggest straightforward solution. And as I keep trying to say, I think it's good quality code, open source code. There's a company behind that also that wants to give you more support in those things if you need it. And you just happen to buy yourself a little optionality. You're just changing gears. You're saying, well, the optionality to me is maybe a little bit better here than the code looking quite the same as you get over in PySpark. So good stuff, good choices. Again, my name was Lester Martin, kind of reached into my talk, and it was really about making sure you understand that Trino is a quality engine, a desirable engine, a reliable engine, an engine that you could run your data pipelines on. Thank you so much.